Hey everybody, Mrs. Bixler, and now we're going to talk about trigonometry, sine, cosine, and tangent in real life. So I know that I've said that sine, cosine, and tangent are just really important tools, and we're going to get to see today and in your homework and in our discussions the way we see trigonometry in real life. So if you look at some of these examples, if you think about like the height of a tree or the height of a mountain, no one ever climbs to the top of the tree or climbs to the top of the mountain and just drops a tape measure straight down and like hopes that it's straight. I mean, obviously that wouldn't even work in a mountain situation, right? And in a tree, it would get all clogged in the thing in the branches and it would be crazy, right? There's no way you could find that height. But what we're able to do because of trigonometry is we're able to figure out, well, I know how far I am from the base of the tree or how far I am from the base of the mountain. And I know using a special tool, often called a surveyor, you see those often at like construction sites. I know what approximate angle here I am looking up at the top of the tree. So I can determine with my nice little right angle what the height of that tree is, or what the height of that mountain is, which is pretty cool. You think about all the stats we know about all of these super tall buildings or tall mountains or tall trees, and we know that all because of trigonometry, which is pretty amazing. So there's a little bit of vocabulary I wanted to make sure that we felt comfortable with. So let's say that you're sitting on a boat. So here you are, you're maxing and relaxing, you're getting a little suntan, you look great. So if you look straight out, that straight line is what we call the horizontal or like the horizon, right? You're looking straight out. And if you look up at your buddy up in the lighthouse, this angle right here is what we call the angle of elevation. That's like the only new vocabulary that you're going to have here in this unit. Well, that's one of two. The other new one that you're going to have is if you're this guy and you are looking straight out, this is also the horizontal for my little guy. So it's basically like relative to where you're standing, right? So if you're looking straight out, even if you're super high up, straight out is what's considered your horizontal. But then if you're looking down at your bud in the boat, this is what we call the angle of depression. So looking up, you've got the angle of elevation. Looking down, you've got the angle of depression. And that is going to inform us a lot when we're given information about real life situations. So here we go. The sun's angle of elevation is 38 degrees. So if I'm down here on the ground, look at my lovely stick figure. If I'm down here on the ground, here's my horizon, right? Looking straight forward. And my angle of elevation would be 38 degrees. So this little guy right here would be 38 degrees. The building casts a shadow of 45 meters. So this shadow would be here, right? Because we always see shadows on the ground. So this would be our 45 meters. And then look, we've got a nice little right triangle here. So here's my 38 degrees. Here's my 45 meters. Here's my right angle. And if I'm interested in how tall the building is, well, that's going to be my height, my x. So oftentimes with word problems, whenever we see the question being asked, that's going to be our unknown, right? That's going to be our variable that we're solving for. And then what would you use here to solve for x? Well, you'd see, oh, I've got the side opposite and the side adjacent. Opposite and adjacent is tangent. Woohoo! So I would do the tangent of 38 degrees is equal to x over 45. And then solve, 45 times the tangent of 38. Good. All I care about here is sort of the setup. All right, now let's look at this one. We've got a parasailer, right? So here's my parasailer up in the little balloon, having the time of his life. I'd be freaking out, but whatever. So it sees the boat at an angle of 11 degrees, an angle of depression. So remember, the parasailer's horizontal is like this. So the angle of depression is going to be from this horizontal down this way, 11 degrees. And so if I know that the length of the string connecting them is 100 feet long, I want to know how far away is that boat. So I want to know like this distance essentially. along the water, how far away is that boat from where the parasailer, like if it were to drop right there? So I've got a nice little right triangle right here. But wait a second, my 11 degrees is not in my right triangle. So here's a little sneak. If you think about it, if the angle of depression down to the boat is 11 degrees, the angle of elevation up to the parasailer also has to be 11 degrees. So the angle of depression and the angle of elevation are always going to be the same. So technically, if you know about parallel lines, and you don't know about them yet in this class, but we've got a little parallel line situation here. Do you see how this and this would be congruent? Cool. All right. So if I were to just extend this, I've got a nice little right triangle. Here's my 11 degrees. Here's my 100 feet. And I'm solving for x right there. So the setup here is a little different than the other one. So versus 11 degrees, I've got the adjacent side and the hypotenuse. So if I have adjacent and hypotenuse, I know it's going to be cosine. So the cosine of 11 degrees is equal to x over 100. You cross multiply, you solve, and you get what x is. Fabulous. The biggest problem here with these problems, not problem, but like challenge, is just drawing the figure. So I want you to pause the video right now and draw these two situations. Okay, we're back. So here you're flying a kite on a 100-foot long string at an angle of 50 degrees of elevation. So I want to know how high the kite is flying. So let's take this guy away. And hopefully your picture, your little stick figure might not be as lovely as mine, but I bet it's pretty good. So hopefully your picture looks something like this. And so for this guy, if we were to solve here, I have the side opposite and the hypotenuse. So if I have the opposite and the hypotenuse, that's going to be sine. So the sine of 50 degrees is equal to x over a hundo. All right, now let's try the other one. So scooch this one away. Here we go. So I look up at the top of the skyscraper at a 72-degree elevation. I'm 50 feet away. Now, how tall is the skyscraper? It's going to be pretty tall. So here I've got opposite and adjacent. If it's opposite and adjacent, it's going to be tangent. So the tangent of 72 is equal to x over 50. And then cross multiply, etc. solve. All right. So now let's look at something you've probably seen before and haven't really noticed and really asked questions about. So there are these signs around, and they're even in Greenwich, where it's a warning to trucks that there is a really high gradient on a road or a percent grade. So these are actually really cool. And this is something that has to do with trigonometry, which is pretty incredible. So if you saw an 18% grade, you wouldn't be exactly sure what that meant. But what if you saw a 100% grade? So let's say a 100% grade, you would know that for every foot you go up, you go horizontal, right? For every foot you're going horizontal, you're going up 1 foot, over, up, right? A 50% grade would be, well, I'm going to go up half as much. So every time I go horizontal 1 foot, I'm only going up a half a foot. And that would be a 50% grade. So watch. If I knew that every time I went up, I only went over 20, I would look something like this, right? So I would be going up 10 and over 20, up 10 and over 20. So in this situation, I know that this angle measurement is going to be the tangent of that relationship, that 0.5 is going to be the tangent of that angle measurement, which is pretty crazy. The tangent of angle X is going to be equal to the opposite over the adjacent. So whenever you see a percent grade problem, it's always going to be this is going to be dealing with this angle right here. The tangent of this angle right here is 8%. But we don't deal with tangents as 8%. No, no, no. We deal with tangents as decimals, right? So the tangent of this random angle is going to be 0.0 8. So in that previous example, the tangent of that degree measurement, if I go back to this original problem, the tangent of this angle would be 0.18. The tangent of angle X would be 0.18. So the first step for these percent grade problems is always to figure out what that degree measurement is. So in your calculator, you would do the inverse tan of 0.08 equals, doing this live, watch out, inverse tan of 0.08 is going to be approximately 4.57 degrees. So I now know that my angle measurement is 4.57 degrees. So I've done that first. Here's my little grouping together of everything. The hill now is 2 miles long. So if this hill is 2 miles, I want to know how high up I'm going to be at the tippy top. So if this is my question, that's going to be my unknown. So now my problem is actually really easy. Versus this 4.57%, degree measurement, I know that I have the side opposite over the hypotenuse. So if it's the opposite and the hypotenuse, I know I'm using sine. So it's going to be the sine of 4.57 degrees is equal to x over 2 miles. And then you cross multiply, not 0.2, x over 2 miles. And then you cross multiply and you solve for x. So the big thing here with these percent grade ones is this first step. So always being able to do the inverse tan of the decimal of this one. So you want to first get this into a decimal, and then you're going to do inverse tan to figure out what that degree measurement is. And then you can solve the problem. I know it's a little tricky. We'll practice more in class. Go ahead, tackle the homework, and I'll see you soon. Good job.